Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited about. So let's go ahead and read the statement. So it says design a class, right, to find the kth largest element in the string, right? It says note that the kth largest element in the sorted order, not the kth distinct element, right? It says to implement the class, right? So pretty much this is the constructor, right? It's given to us, right? So we're going to be given a k and a array of integers, right? And we need to initialize the object with the integer k and the stream of integers that's going to be given to us. What I'm saying. So our job, right, is going to be to keep track of the key largest numbers. What I'm saying. So it says end val, right? So every time they're going to call this add function, right, where they're going to try to add some numbers to the object, right? And our job, right, is to return the kth largest element in the string, right? So every time we need to return it, what I'm saying, they're going to keep adding numbers, and every time they add numbers, we need to return the k largest number. So if k is 1, right, means return the largest number in that string, right? K is 2, return the second largest number, I'm saying. In case 3, return the third largest number, I'm saying. So good data structure. So how are we going to go about solve? So let's go through this example, right? So we got k, right? See, it's initialized with this, right? And then we got several add functions that helps us, and then those are the output, right? So we're gonna go a couple over example in a little bit, right? So the way, so guys, every time you guys hear the word k largest, k smallest, top frequent, always think of using a some kind of heap, right? Heap is a very good data structure in helping us solve this kind of problems. I'm saying I know there's some problem we could use quick select to solve the problems, but most of the time heap can suffice in an interview, right? But if the interviewer wants you to use quick select, then you go ahead and implement that. But every time I hear the word k, automatically my brain goes to using a heap, right? So I want you guys to gain the same intuition as well, right? When it comes to doing this kind of problems. So yeah, guys, we're gonna go over this example, right? So let's go. Yeah. So yeah, guys, we're gonna go over those examples really quickly, okay? So what we have here, guys, we have a pretty good one, right? So it gets initialized first, right, with 3. So we need to return the third largest number, and those are the numbers that we're gonna initialize the object with, all right? So 4, 5, 8, and 2, right? So we started off, right? So we add 4 to the thing, where we add 4, boom, to the heap, right? And then we add 5 to the heap, right? We add 8 to the heap, right? So a min heap, right? I'm gonna tell you guys exactly what we use a min heap, right? So yeah, we use a min heap, guys, because right, so we want the largest numbers to be at the bottom, right? So that we're gonna have access to all the small elements, right? So when we go over size k, when the heap size goes over size k, right, the smaller numbers are gonna be out of there, right? And the largest numbers are gonna be still in the structure, allowing us to preserve all the k largest numbers. I'm saying, so it's a very, very good way of doing this, right? Just like if it was the kth smallest numbers, right? We would use a max heap that would allow us to keep all the smallest numbers at the bottom, and all the large numbers will be out of there. I'm saying, just same concept. I know it's reverse logic, but that's how it works, guys. I'm saying, yeah. So we add 4, right? We add 8, right? After we add 8, we need to add 2, right? So after we add 2, guys, we see that we go over the k size k, right? That it was initialized with, right? So the size was supposed to be 3, right? Of size 3, not more. I'm saying, so since it went over the capacity, right? We need to remove the smallest element in the heap, right? So remove that. It does its magic, hippifies, and then that cost us log k. You know what I'm saying? Yeah, so it's a good thing to keep in mind, right? So now we're returning. So now the third largest number now is 4, right? Obviously, I'm saying it's pretty obvious here, right? So now we call the add function, right? Add we call 3, right? 3. We add 3 to the main heap, right? Heapifies, right? And then when we add 3, right? Since now the heap is over capacity, guys, we need to remove the smallest element, right? So that it could be exactly of size 3. I'm saying, so that we can have the third largest number at the top, right? And then we just return on the top largest, right? So we return, after we add 3, right? We return 4 as the third largest element in the stream, right? And same thing, guys, we call the function add 5, right? We add 5, we insert 5 into the main heap, right? And then now it's over capacity, we gotta remove, right? So now we return 5 as the third largest element, right? I'm saying, because it says there's gonna be duplicates, so yeah. And the same thing, guys, we continue doing this. So we add 10, right? Choose this one, right? Add 10, right? After we add 10, guys, no, we need to remove the smallest, right? So that it could go the size, I'm saying. So now 5 is the smallest, right? And then we do the same thing, guys. We add 9. We are over, right? So we need to remove that as well, right? Heapifies, and then now returns 8, right? As expected, right? And 8 is indeed at the top, right? So that's how important it is, guys, I'm saying. And then we add 4, right? 8 should be at the top, I'm saying, after remove it, and then 8 is gonna go at the top, boom, easy, you know what I'm saying. That's how we end up every time we do the same operation. We add it, we are over capacity, and then we remove the smallest number, and then all the k largest numbers are gonna be in the data structure still, I'm saying. Pretty simple. So let's go ahead and do the implementation, all right? Yeah, so we're gonna implement it, right? Hopefully you guys were able to follow the logic, right? And the thought process that I did, right? Especially with the visualization that I kind of helped you guys, what I'm saying? So now we're gonna, guys, we're gonna have K be as one of the properties of the class, right? And also we're gonna have a main heap, right? Which is a priority queue, right? Priority queue, right? Comment heap. All right. So when we need to initialize this, initialize the data structure, right? So we do this k, right, is equal to the k that's passed in, right? So we initialize it, right? So this k is pretty much saying this object's k, you know what I'm saying? So referring to this k, right? We initialize it with the k that's passed into us, what I'm saying? Passed into the constructor to initialize our k with the k that they want, right? The capacity, I'm saying. And then what we're gonna do, right? We're gonna loop through the numbers in the array, right? So we're gonna do int num and nums, right? So for numbers in the number array, right? We're gonna add it. So we need to make sure that we initialize space forward main heap, right? So priority queue. All right. So by default, no, the priority queue is the main heap. So yeah, we're good on that. So so the main heap, right? So we add the number to the heap, right? Just like, remember how I was adding numbers? This is exactly what it's doing right now, right? And then after we do that, guys, we need to check, right? Are we over the capacity that we talked about? If we, right? So if main heap dot size, right, is greater than k, right? What I'm saying? We're gonna be need that greater than k. We do main heap that poll, right? That pretty much helps us in removing the smallest number, I'm saying. And then yeah, so after that, I think we're pretty set. So we initialize k, and then we initialize the heap, right? And then we add numbers, and we over capacity, we remove the k, right? So likewise, right, guys, we do the same thing. Main heap that add, we add the number, right, val, right? And after we do that, right, we check before we return the smallest, the kth largest number, right? We need to check, does main heap that size, right? Is it greater than k? Then this that k. You know what I'm saying? If it's greater than k, right? If it is, we need to remove the smallest number. The same algorithm that I just did, right? When I did the operation, you know what I'm saying? And then guys, you know, we're gonna be pretty good shape, right? So we just return min heap that peak, right? Because we don't want to remove it, we want to peak it. We just want to return the, so for them to know the kth largest, what I'm saying, we do peak to just, hey, here's a sneak peek of that, right? We're now gonna remove it. Poll removes the smallest element at the top, right? Peak lets you know which element lets you have a peak at the smallest number, right? So yeah, let's try to run these small test cases, see if we pass them, right? So forgot about that. We need to add on for integer, right? So it knows which one it is. Might be. All right, so we were good. And then yeah, so let's try to press on submit, see if we pass all the test cases. Yeah, guys, we were able to pass all the test cases, guys. You know, I want to thank you guys for taking the time to watch this video. If you guys found value and if I was able to help you guys, please give me a like. And also, if you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this video, and I'll see you guys in the next one.